VTP messages are sent using the following MAC address, which is a well-known multicast address for the flooding of CDP and VTP messages. Now, there are three types of messages in VTP. There are summary advertisements, subset advertisements, and advertisement requests, and I'll explain each of these in more detail in a moment. But for now, just be aware that there are three message types that help VTP propagate VLAN information between switches. Cisco switches by default belong to the null VTP domain. You typically put your switches into a specific VTP domain so that switches within the same domain can exchange information with one another. It is possible to put switches into different domains, and switches will only update other switches in the same domain. A switch can only belong to a single VTP domain, and by default a Cisco switch doesn't belong to a domain, but it will automatically join a VTP domain when it receives an advertisement for a domain over a trunk link, or you can manually add the switch to a VTP domain. In this example, let's assume that these devices have been put into a VTP domain with the name of Cisco. Please remember that VTP is a layer 2 protocol and requires trunk links for communication, so VTP advertisements will not traverse a router. An important concept to understand in VTP is the concept of a revision number. Every time a change is made to the VLAN database of a switch, the revision number in VTP will increment by 1. So if you add a new VLAN, delete a VLAN, rename a VLAN, the revision number will change by 1. So let's assume that all devices in this topology have a revision number of 1. You as the administrator add a VLAN, let's say VLAN 3, to this top switch. The revision number on that switch will then increment from revision number 1 to revision number 2. That information will then be advertised to all other switches in the VTP domain so that they can synchronize their VLAN databases to the latest revision number, which is revision number 2. The switch at the top will then send what's called a VTP summary advertisement to all other switches, informing them that changes have been made. Now, the VTP summary advertisement message is sent as a multicast, so all other devices in the layer 2 domain will see that message, and they will then request the latest information from the top switch using what's called an advertisement request. So the top switch sends out a summary advertisement. The other switches hear that something has changed. They then request those changes from the top switch using an advertisement request, and the top switch will send detailed information about the VLAN changes using what's called a subset advertisement. All of the switches in the same VTP domain synchronize their database to the top switch, and their configuration revision number will change to be the same as the switch where the changes were made. So if you look at the VLAN databases of these switches, VLAN 3 will now be shown in the VLAN database, and the revision number in VTP will be revision number 2. So the whole concept of VTP, once again, is that you make changes on an individual device in your layer 2 topology, and those changes are advertised to other switches, which in turn synchronize their VLAN databases to the switch that has the latest revision number. That means that all switches in the layer 2 domain end up having the same VLANs in their VLAN database as the switch with the latest information. That means that you as the administrator only need to make changes on one switch rather than the 5 switches shown in this topology. Once again, be careful. VTP does not put individual ports into VLANs. You as an administrator still have to configure a port such as gigabit 101 as an access port and put it into VLAN 10. VTP simply updates the VLAN databases of switches so that they know which VLANs exist in the topology. Trunk ports on Cisco switches by default permit all VLANs, so traffic for any VLANs that exist in the VLAN database will be forwarded, but any access ports that exist in your topology have to be manually configured and put into the correct VLAN. VTP is once again simply a VLAN database update mechanism that allows switches to know which VLANs are configured in the topology. Individual access ports need to be manually configured and put into the relevant VLAN.